Now that you've had some practice on sketching exponential graphs, I want to show you a condensed list of some of the properties. So the properties of an exponential graph I'm going to outline correspond to having a base that's bigger than 1, such as maybe y equals 2 to the x, or y equals e to the x, or any kind of base that's bigger than 1. The domain for all exponential functions is all real numbers. The range is all positive values. The x-intercept, there are none. It will never cross the x-axis. Remember, this is without any shifting, just your basic exponential graph. The y-intercept will always be this key point, 0, 1. Plug in 0 for x, your output is a 1. The horizontal asymptote is going to be the x-axis. That's the line y equals 0. The function's increasing for everywhere from left to right, and that's because your base is bigger than 1. It's increasing as you go from left to right. It's smooth and continuous. There are no corners, breaks, holes, gaps, vertical asymptotes, things like that. And it will contain these these 3 key points. However, I like to focus on this point right here, and everything else just kind of works its way out. Properties of a graph where a is a base that's between 0 and 1, such as maybe y equals 1/2 to the x power, something like that, they're very similar to what we've just discussed, except now your function's decreasing because this basic graph is going like this. Okay. And then once again, you've got this key point, 0, 1. Let's see what else. The exponential functions are 1 to 1. We talked in the previous videos about a 1 to 1 function. Do a quick horizontal line test. You'll see that you never cross more than once. Therefore, their inverses are functions. And spoiler alert, the next section we're going to discuss is going to refer to the inverse of an exponential function, which is your log functions, not lag. Log functions. So when we get to the log functions, you'll understand what I'm talking about. The number e, as I discussed, is an irrational number. Technically, it's the output. If you plug in a very large number for x here and here, you'll see that your output values approach this 2.71828 value. Very large. I would try using x equals 100. Try using x equals 1,000. And if your calculator allows it, you can get even bigger than that. But those are the output values you will see e approaching. Laws of exponents. So I'm going to just not going to read these all over. You can pause the video to examine these more closely, but I'm going to start using those properties now in some examples. Okay. To solve an exponential equation, which is an equation with the variable and the exponent, you need to rely on a lot of those properties of exponents. The idea is you would like to get the same base on both sides. Do you see this idea right here? That is what we are going to be using whenever possible. In other words, if you have the same base on either side of your equation, you can simply make an equation out of the exponents. It's almost like those bases magically disappear. Now, obviously they don't. It involves using the logarithm, but we're not going to discuss that until the next section. So on 68, on the left side, the base is 5. On the right side, the base is 1/5. We have to figure out a way to make them match. How can I change what 5 looks like? Or how can I change what 1/5 looks like in order to the bases to be the same? Turns out you can write 1/5 as 5 to the negative 1 power. And if you write 5 to the negative 1 power, you will end up getting an equation that says 5 to the x plus 3 equals 5 to the negative 1. Now that you've got the same bases on both sides, the bases drop off, and you can make an equation out of the exponents. And so the exponents give you the equation x plus 3 equals negative 1, or x equals negative 4. And that's your answer. The next example, we have a base 4 on the left side and base 2 on the right side, we need to attempt to make those bases the same. And so what I'm going to do is rewrite 4 and rewrite 2, maybe just one of them, into its other match. And you can change the number 4 into 2 squared, right? 2 squared is the same as 4. Now don't forget what was happening before we made that swap. That's still there. Properties of exponents tell you that when you have a power to a power, like we have here, we can multiply those two powers together, and we are going to get 2 to the 2x squared equals 2 to the x. Now that you have the same bases on both sides, same base here as you have over here, you can drop off those bases. Like I said, it looks like magic, but it's really not. And come up with an equation that just has the exponents equal to each other. All right, we solve for x by getting all of the x's on the same side. 2x squared minus x equals 0. So factor out the x, you end up with 2x minus 1 equals 0. And let's keep going. Set each factor equal to 0. We get x equals 0, or we could have 2x minus 1 equal to 0, where this one gives us x equals 1/2. We have two answers. We have 0 and we have 1/2. Next up, we have a base 9, we have a base 27, we have a base 3. We want to attempt all those bases to be the same. I think our best bet is to change everything into base 3. So change 9 into 3 squared. Change 27 into 3 cubed. And this does not change at all. Properties of exponents tell us that when you have a power to a power, you multiply. We end up getting 3 to the 4x times 3 to the 3x squared equals 3 to the negative 1. We have another property of exponents that tells us when we are multiplying same bases together here and here, we will end up adding those exponents. We're going to be adding the powers. Property of exponents allows us to say that. So now we have 3 to the 4x plus 3x squared equals 3 to the negative 1. We now have the same base on both sides. And so therefore we can rewrite our equation with the exponents equal to each other. 3x squared plus 4x equals negative 1. Solve for x, get everything on the same side, and factor. Okay, let's see how this is going to factor. Shouldn't be too hard. I'm going to do a quick mental FOIL to check. 3x squared, 3 and 1 is 4. This looks good. You get two solutions. X is negative 1/3 or x equals negative 1. And that's it. Please pay attention to the updated schedule that I emailed everybody so that you are staying on top of the homework. There will be no late assignments accepted online in MLP. It's going to, actually, let me change that. I do believe I still allow late assignments, but in the event that I don't, I have to go back and check my settings. Make sure you are keeping on track with the homework assignments so things don't pile up on you towards the end of the semester. You don't want that to happen, especially right before a test. You don't want to be spending a lot of time doing all of your homework that you put off for the next couple of weeks. So we are finished now with section 4.3. You can do all of the relevant homework assignments that are due to then.